Hi everybody, this is Miss Denton, and this is your last video in your G13 series. I know the other two videos have been pretty long. There's been a lot to talk about. We are studying all these formulas that the formula sheet gives us. We get all these formulas from the SOL formula sheet, and we have to know what to do with them. We've studied, in our first lesson, we studied two-dimensional area. So we've studied all of these area formulas, the first 6 shapes here. In our second video, we studied lateral area and surface area. And that took a while. We got through every single figure, and you now know, hopefully, what all these letters mean when you're looking at a lateral area or surface area formula. In this video, we're going to look at the last piece here, which is the volume of these three-dimensional figures. So again, we have 6 figures to look at, and we're going to run through an example of each one. Okay, first of all, make sure you understand what volume is. Okay, when you're asked for the volume of a figure, you're talking about how much space is inside the figure. A simple Google search here, I just said, volume definition math. Volume is the measure of the amount of space inside of a solid figure, like a cube or a ball or a cylinder or a pyramid. Its units are always cubic. That is the number of little cubes that fit inside the figure. Okay, so we're not going to write all that down, but we are going to write this part down. That volume is the measure of space inside of a three-dimensional figure. Okay, and very important, it's measured in cubic units, like feet cubed or inches cubed or centimeters cubed, whatever, so on. Okay, so it's the measure of space inside of a three-dimensional figure, how much it takes to fill up that figure. All right, and we're going to start with our rectangular prism. Okay, so let's see here. I pulled this formula straight off the formula sheet. Volume is equal to LWH, where L is the length, W is the width, H is the height. Length, width, and height. So let's start with that formula. Length times width times height. So you need to look at the figure and pick out what you think the length, the width, and the height are. I'm going to label 10 as the length, 16 as the height, and 5 as the width. So when I put it into my volume formula, I've got 10 times 5 times 16. Okay, I've got my calculator handy again to show you guys how to type this all in one line. This one's pretty easy. 10 times 5 times 16 is 800. Okay, so what does that mean? Let's take a look. That means I could fill this box up with 800 tiny little 1 by 1 by 1 cubes. If I had all these teeny tiny little 1 centimeter by 1 centimeter by 1 centimeter cubes, I could take 800 of them and fill up this box with those cubes. That's what volume is. It's the amount of space inside of the figure. It's always a cubic measurement because we have now used 3 dimensions to find that value. We used a length, a width, and a height as our 3 dimensions. Okay. All right, next, let's look down here at the cylinder. Cylinders, okay. Volume formula. V for volume equals pi times r, which is radius squared, times h, which is height. Volume equals pi times radius squared times height. Okay, if I'm looking at this picture, And when I'm looking here, it'd be really tempting to throw 15 in for the height. But realize this cylinder is not sitting on its bases. The bases of the cylinder are the circles. So this has been tipped over. Okay. So you need to, in your mind, tip it back over. And that would make 9 the height. And it would make 15 the width of the entire cylinder. Now I only want the radius, so I don't want 15. I want half of 15, which is 7.5. We cut it in half. So our volume is equal to pi times the radius, 7.5 squared, times the height of 9. Now, just like with surface area, you might need to come up with an exact volume as well as a rounded volume. So to find the exact volume, I'm not going to include pi in my calculation. 7.5 squared times 9 is 506.25. 506.25 is the 7.5 squared times 9. Pi has not been used yet, so it's still part of the number. So this is 506.25 pi meters cubed. That's our exact value, which is not super helpful if you're really trying to say how many cubes fit inside that cylinder. So let's go ahead and find the rounded value. 506.25 times pi. Take my last answer and multiply it by pi. So 1,590.43 cubic meters fit inside of the cylinder. 1,590.43 about, that's our rounded value. So about 1,590.43 little 1 by 1 by 1 meters fit into this cylinder. So you need to be able to find both, just like we've studied for the rest of this unit. Exact values and rounded values. We are moving right along. Pretty quick now. Volume of a sphere, check out that formula. Volume is 4/3 times pi times the radius cubed. That's where we're going to get our cubic value this time. The radius cubed. Okay, well in our picture it'd be real tempting to just throw 24 in there, but be careful. 24 represents that full diameter all the way across. So you've got to split it into 12 and 12. So volume is 4/3 times pi times 12 cubed. Let's get our exact answer first, and then we'll go back and get our rounded answer. Exact answer is 4/3 times 12 cubed. Here in my calculator, fraction is control divide, 4/3 times 12 cubed. Now we've gotten square. There's a little button for squaring. We want to cube 12. So you need this up arrow right beside the x squared, and that's going to create an exponent box. And then put a 3 in there. So this upward facing arrow will open up an exponent box. That is 2,304 as our exact value. We have not used pi, so that's 2,304 pi millimeters cubed. Okay, let's go multiply that value by pi to get the rounded answer. 4,304 times pi is 7,238.23 millimeters cubed. So that means 7,238.23 tiny little millimeter by millimeter by millimeter. I can't even draw it so small. Okay, but that might be a millimeter by millimeter by millimeter, and 7,238.23 of those fit inside the sphere. Okay, we are halfway done. Let's roll. Keep going. Flip over with me. All right, in this next example, we're looking at the triangular prism. The volume formula given to you off your formula sheet is capital B, which stands for the area of the base, times H, which stands for the height between the bases. Okay. So we have a side project to do. First thing we have to do is figure out what the area of the base is, which means you need to decide where the base is. Okay? Remember, in a triangular prism, the bases are these parallel triangles, these parallel figures here. So our parallel figures are front and back. Use your 3D vision here. The triangle in the front and the triangle in the back represent the bases. I'm going to highlight one in pink, just like I did in the last video, and I'll highlight the other base in blue. Maybe that'll help you see it better. Okay, so there's our two bases. So you need to know what the base area formula is for a triangle, and that's where your formula sheet's going to come in handy. Go back up here to your triangle from the very beginning of this unit. Area formula for a triangle is 1/2 base of the triangle times height of the triangle. 1/2 base of the triangle times height of the triangle. Okay, remember, this is height of the triangle versus in the volume formula, that's height between the bases. So those are two different heights. So this is just a little breakout that we're going to work on. So I think we need the pink and blue triangle combined. The height is definitely that perpendicular piece of 4.1. The base runs perpendicular to the height, and there's no value given here on the blue triangle, but if you look straight across to the pink triangle, you'll see that it's 12. The base of that blue triangle is 12. So our base area here is 1/2 times 12 times 4.1. 1/2 times 12 times 4.1 is 24.6. If you have a really good memory for numbers, you might remember that from our surface area. I'm using the exact same pictures I used for our surface area and lateral area notes. So you may recognize these values. So our base area is a 24.6. So back to the volume formula. Base area is now 24.6 times the height, but not the height of the triangle, not the 4.1. We're talking about the height between the bases, and that is 3 kilometers. The height between the bases is 3 kilometers. So 24.6 is the base area, and 3 is the height between the kilometers. So 24.6 times 3 will give us our volume. Our volume is 73.8. And what are we measuring in? Kilometers cubed. kilometers cubed. It is a three-dimensional value. Okay, wonderful. Let's move on down to this pyramid. Okay. These two formulas are so similar. The volume formula for a pyramid is 1/3 times the base area times the height. 1/3 times the base area times the height. Okay, so again, we have to do a little breakout session to solve for B. Let's look at the base of this pyramid. The base of our pyramid is 16 by 16, which means it's a square. So this is a square pyramid. Okay, I'm looking at the formula sheet for the area of a square. There's my square. Area of a square is area is equal to side squared. S squared, S for side. All right, so side squared is what we'll find the base area. And our side values are 16. 16 squared is 256. So our base area is 256. Now bring that back into the volume formula. That's 1/3 times that base area of 256 times the true height of the pyramid. No mention of that slant height that we talked about in our last video. This is the true height at the perpendicular, which is 3. And I don't think I even need to grab my calculator here because this is just going to work out nicely. 1/3 and 3 are going to end up canceling each other out. So I'm going to get 256. Now, if you don't believe me, let's go over to the calculator. 1/3 is a fraction. 1/3 times 256 times 3 is 256. That 1/3 and 3 just ended up canceling each other out. So the volume is 256 feet cubed. Cubic measurements for volume. It does seem weird that our base area and our volume are the same, but remember, our base area is in feet squared. It's just talking about the area of that flat square versus how many cubes will fit inside this pyramid. Okay, on the final piece here, the volume of a cone. Let's take a look. Volume formula from your formula sheet is 1/3 pi times the radius squared times the height of the cone. All right, so let's look at our picture, see what we can include. We have no radius. Our volume is going to be equal to 1/3 pi. We have to stop and figure out what the radius is. And then we have two different heights given to us here. We have 27.3, which is called the slant height, versus 25.2, which is the true height. I want the 25.2 in my formula. All right, so we need to do a little bit work on how to find this radius. Let's draw in a radius. Okay. This is the radius. I hope you recognize that you have just built a right triangle. I'll highlight it in blue here. Anytime you can build in a right triangle, you've got some skills you can use to solve on that triangle. Here I'm going to use Pythagorean theorem because I have all three sides of the triangle. Pythagorean theorem is a squared plus b squared equals c squared. A and B are legs. C is hypotenuse. Well, the hypotenuse is always across from the 90-degree angle, so the 27.3 is the hypotenuse. That means the radius and the 25.2 are the two legs. All right, using my calculator, I'm going to go ahead and square these in the calculator. 25.2 squared is 635.04, and 27.3 squared is 745.29. So I've replaced these squared values with their simplified version, and now I need to solve for the radius. So I'm going to subtract the 635.04 from both sides. That will leave me with radius squared is equal to 745.29 minus 635.04 is 110.25, and I'm almost done here. That 110.25 is equal to the radius squared, which is actually what this calls for, radius squared. Okay, so if, I'm going to jump down here a second, 1/3 pi times radius squared, and this is my radius squared, so I know that's 110.25. Now, if I didn't recognize that that was radius squared and I just wanted to plug in the radius, I would have to go one step further to solve for r, which means I'd have to take a square root, because a square root and a square cancel each other out. Square root of the 110.25 is 10.5, so the radius here is 10.5. If the radius is 10.5, I can plug in just 10.5 into the formula. So you have options here. Okay. All right, anytime we have a pi in our process, that means you're going to come up with an exact answer as well as a rounded answer, because you don't know what type of answer choices are going to be available in your multiple choice. So first, for my exact answer, I'll type in everything except pi. 1/3 times 110.25 times 25.2. I'm getting 926.1, 926.1, and we haven't used pi yet. So 926.1 pi inches cubed, because we're measuring volume. And for that rounded answer, I'm just going to take that 126 or 926.1 and multiply it by pi, for a total of 2,909.43. 2,909.43 is our rounded value. Exact value, rounded value. You guys, great job hanging with me as I do some examples straight from our formula sheet. This has been a long explanation throughout this unit as I do example by example. I hope that I've answered all your questions about the formula sheet, because the formula sheet is really no good to you unless you know how to use it. So please come see me if you have any questions. I'd be happy to answer those questions for you and do some practice problems with you. Happy studying!